So
Oh, you
welcome to
want
the
to
developer
record?
meeting.
Oh,
So
I will
today
take
we have a
bigger.
special. Ido is giving us an intro into ROS2 and how we shall implement it. Ido, your stage.
Yeah. Well, I didn't prepare much, honestly, but I'll show the demo. I created a bit more stuff on top, and we can discuss if someone has questions. What I'll suggest is really for whoever wants to learn. The tutorials are really, really good. If you guys need help, I think it's better to do like one-on-one, and just ask me when I'm available, and I can walk you through. And otherwise, it will just totally time consuming to set up everything. But I will share my screen. Uh, Again, my screen is super wide, um, so let me know how it looks.
Can I ask a question?
Look,
Um, do you Ido, do you have like commercial experience in with ROS2? So is this something you work on a day-to-day basis with, basically?
I cannot confirm or deny anything
Okay.
about that. Okay.
Okay. No. I'm just trying to understand if because I've just like I'll have some questions with regards to service boundaries and that sort of stuff, and what should go into becoming a service, and how do you group functionality together, those sorts of things.
Okay.
I wouldn't mind having a chat with you about that at some point.
Yeah, sounds good. Yeah, so there is no really like grouping functionality the way you think. Okay, the idea of ROS2 is really built on top of publish subscribe of topics. Okay,
Yeah.
for example, here, let me just move this to the center. Do you see the RQT window with the diagram?
Yes.
Yes.
Okay. So what you see here that I have a video for Linux, a camera driver, and it's publishing multiple topics. There is the parameter events of the camera, there is the image raw of the camera, and the image raw compress. And if you look on the left, I'm actually subscribing now to the topic of the compressed, and I'm getting about 6 hertz, which is um, if you look down here, this is like the maximum resolution of my camera. That's the max capacity it can do at full frame. Now, if you look at if you look at the performance here, this is about like 30 megabit, whatever. Right now, the compress, if I take a deep look into it, second, it's a mono H JPEG compression. Okay, the quality is always going to be improved. I'm not worried about that. Right now, I'm worrying all the piping. Okay, now what's important here is everything is configurable. So there is parameter events that I can go and tune on and off, change resolution, do whatever I want with the driver, change how the compression should work. All of that is available in runtime. Me myself, I'm getting familiar with more how to do that. Right now, it's more about building all the different Docker components of what we need and can establish it in place. Now, bear in mind here, what I'm showing is zero code. I didn't write any code. The only code that I have, it's really like this piece, which is the Docker image. So I'm starting with ROS latest, and I'm doing an upgrade just to get the most recent binaries, because they don't have the latest image for some reason. And I'm installing the video for Linux camera driver, and I'm installing the image transport plugin. The moment I'm installing the image transport plugin, every time you publish a raw image topic, you will also have a compressed topic. Now, bear in mind that if I stop it, you'll see like the bandwidth changes to like a megabit, whatever. That's like this BTOP. But nothing really works when there is no subscription. Okay, so the publisher don't publish anything unless there is a subscription for it. The reason for that, it's why it's designed for real-time operations. Okay, so once there is a subscriber, that's when it starts to optimize stuff. So if I subscribe to like the raw images, you'll see now that the bandwidth is almost like a gigabit here, and that's the images. There is a bit more CPU, but nothing really changed. And you see I'm getting still the 6 hertz on the raw. If I click on the compressed, you'll see that that's now 30 megabit. The 1.5, sometimes it has like this miscalculation here. So refresh, subscribe again, it will fix it. Yeah. So I'm doing 6. Okay. Now.
I have a question.
Yeah.
Is these 6 frames per second, is it the camera limit or a buffer limit? Or?
Yeah.
Okay, it's the camera limit.
Yeah. So, for example, I could do, instead of a full RAM, I could do like a low res, low res, let's say. And if I'll publish, you see that goes up to 30 now.
Ah, okay, yeah.
And that's my next image 10, really. That's like, there is still way to configure it more. It's not like the best driver, but again, it's raw. So whatever I'm consuming and the compression and all of that will work the same way. It doesn't matter. I can always fix the driver, make it better perform, make it improve, higher resolution, whatever, right?
Yeah.
The next step that I'm going to do is I'm going to integrate it to object detection, right? So there'll be like a stream that will do object detection. I will have another process that will do that. And then, again, once we have our smart tracker working, right, we can integrate that and replace the processing, but still utilize the same topics. So think about it like as a Lego part that you plug and play, right? That's the end goal, right? Right now, this is really just like a play. So if I do like a make a run, sorry, I need to stop everything. And you'll see in a second how it all works. This will die in a second. Yeah. So if I do make run, so I'm stepping into our Sky 360 development environment. If you remember from last time, I have here the ROS2. Okay, so if I do ROS2, I have the commands here, and I can use everything. I can do like a topic and whatever, and realize like everything. I can publish. I can do like a list, see what's going on, right? Now, the next step is actually, and that's where I didn't have time. I really wanted to do it for today. I just didn't have time and I was really sick. It's really to create our workspace where instead of running like ROS2 commands, I'm actually pulling the source code of the plugins that I'm using. So I'm minimizing, instead of installing a bunch of plugins, I'm only using what I need. So that will be like, for example, NVIDIA for Linux or another driver. The stuff you'll see, the source code will be here because it will be like a Git clone under our workspace, and then we compile that workspace and run it. So we will have a workspace for our like Raspberry Pi, a workspace for our Nvidia, and they will collaborate together, to take the raw images, compress them, send it, and then subscribe to the compressed images, unwrap them, do object detection, publish the object detection, and then whoever subscribed to that will get the detection, right? Now, the end goal is really to optimize it. Thinking about the fisheye camera and the high resolution, right? You probably don't need all the frame per second to understand that you need an object detection. So object detection will probably need like a less hertz per second, probably not 6. 1 or even 1 every 2 seconds, most likely in the beginning will be enough. And the reason is the moment we detect an object, that's where we can start telling the camera, hey, don't give me the entire full frame, I just need a larger box than when the detection was. And that's a very advanced optimization. It will not take us several months to do it. It's most likely the next coming years. But think about it, that you have a fisheye that sees the entire sky. Something moved, let's say every 2 seconds you saw something, and you start increasing the frame rate around that object, get a much better detection, and then you can point the PT, whatever we will decide, and start really tracking it, and have another stream with a much higher quality. But right now, I'm really focusing on like the end-to-end, make sure all the components of the Lego are there, and then like we can start looking at one by one and optimizing it, and changing the drivers to be like the INDI drivers that are far more accurate, or working with the motor properly, and so on and so forth.
May I ask you something here?
Yeah.
You were mentioning that the sorry, I lost myself here.
Yeah.
So what you said before, can you repeat? Sorry, I overtook myself. So the last topic you said about the camera, it was...
Yeah, so the idea will be to replace the camera driver.
That you change let's say the frequency how we receive the images depending on an event, whether it's an event or not.
No, right now it's simple. Okay, it's straight off what's coming with ROS2. I'm using whatever is available, all the plugins that already exist. For Sky 360 in the future, once we have everything working, we will build our own drivers on top of INDI. Okay.
Yeah.
So we will communicate with the physical device using INDI. Right? And but then we'll convert the INDI, what we receive, to ROS2 for all of the other part of the system. Okay?
Yeah, okay.
Yeah. Now, the reason for that is it's actually easier to develop. It will not require everyone to have all the sensors, all the cameras and whatever. They can buy simple, motors, very simple camera, like a USB camera, that I'm using right now that you can see me. You can plug it in and it will work the same way. And the object detection can be like a simple object, like face, whatever. It doesn't really matter what. Okay? But the idea is to improve it, improve the classification. And then, several of us that has the fisheye like myself, I will most likely very soon will put it out, start receiving all the data, and every time there is a detection, I will have a video of it, right? A full frame video, whatever I can capture. Now,
when you say you have a full frame video, you mean from the PDF, or you still mean from the fisheye?
From the fisheye, I still don't have
then my question is as well. So there's not only one event at the same time. There's always multiple events at the same time.
Yeah.
So, is it like you say that, or maybe I understood it wrong, that you switch from, let's say, 6 frames per second to, let's say, 30 frames per second stream on a certain event? Is that what you mean?
It could be, yeah. So it could be that I will decide to to read instead of the full frame, like several aspects of it. Okay, just in a high resolution, but because it's a small box and not the entire full frame, I can read it in much faster frame per second, right? That's one way. Another way is actually because it's a fisheye and it reduces everything. It could be that the compression that we have, even if it's lossless, might be able to show you something that you wouldn't see if it's a full frame.
Yeah.
Okay. It really depends. For example, you can configure JPEG compression to make it super noisy, right? That even if the IAS, you'll see it like it's a big white box, for example, like bigger than what it is, which is what we really want, right? There are techniques to do that. Again, time I did it was over a decade ago. I need to refresh on how to do that on ROS2. It should be possible.
It is. It
I'm
really
sure
is.
someone
Yes.
there, yeah, I'm sure someone there already did some stuff like that. Right?
May I interrupt here just for our common understanding what you were talking about? So basically, we have a full frame stream of, let's say, 6 frames per second, just an example. And if something is detected occasionally, then a part of that stream is taken out and streamed with a higher frame rate. Is it then a cropped material that you're talking about?
Not exactly. So think about it as a control system, right? The control system has available 6 frames per second full frame with my camera, right? But now I can have a subscription for object detection that tells me, hey, I'm going to do it 1 frame per second. I don't need more than that, right? So he will work in 1 frame per second on a low resolution and a compress of JPEG, whatever its request, that's what it's going to receive, okay? Once there is a detection, another process or another robot part really will say, hey, I'm interested in high resolution, of this box. I'm subscribing to this specific topic. So that will force the driver to change how it works, right? To provide the more high accuracy, okay? And while still remaining the 1 full frame per second for the object detection, right? It will start toggling.
So the preprocessor, the part that prepares the message or the data that is then sent, that has then to be in connection with the tracker, so that the tracker says there is something, that it then says there is something that I have to crop out if it is requested for me.
Yes. So the tracker says, hey, I have something, right? It raises what is called an alert, right? And now you have an alert process that says, okay, now I need much better data, right? So please, guys, start providing me, more high resolution on the on this box that is a bit bigger than what the tracker provided, right? Does that make sense?
Then the tracker provided bigger than the tracker provided?
Yes.
So it's like having a bounding box around the object in the size that we define, and then this bounding box, the resolution within this bounding box is set to high, and only this part is provided to the tracker.
No, not exactly, because the tracker, truly today we have a tracker that works on like YOLO, right? Like you only look once, right? So what happens? It will start toggling. It will be, let's say, 20 frames per second on a specific bounded box, okay, for where the object was detected somewhere in the middle. And then there will be still the full frame, one per second or 1 every 5 seconds, doesn't really matter, that gives everything to the tracker, right? So I'm starting to receive far better information. Think about it, how our eye works, right? When you're focusing on something. So you're forcing the sensor to have better focus on a smaller piece with a much higher frame rate.
So if now
this is what I meant.
Yeah, excuse me. So if now are more than one event, and that's normally the case, you always have insects and birds and planes at the same time. So then you create three streams. So for every event, there should be created a new stream.
So again, streams are not a problem. Okay. And yes, in one way you create a stream, but don't think that the streams are working. They only work based on the demand of the subscriber. Okay. So think about it this way, right? And let's say that my camera delivers up to 6 frames per second. Now I'm putting my stream. I'll give you my public IP, and I say, hey, you can subscribe to my stream. You can decide to subscribe because it's a lot of data. It's a gigabit. Let's say the raw images. You can subscribe to the compressed images, and you say, I want from Midor, a sky view once every 10 seconds. I want the full frame, right? And a Christian can decide, hey, I want a 5 per second, right? So my camera internally will walk 5 per second. Okay, but the publisher will send you one every 5, and it will send 5 times a second to a Christian.
Okay, got it. But
optimizing
to clarify this for all of us, Christian, can you give us real figures?
So with the QHY183 camera, we are looking to have a baseline of 20 frames per second, and because this is the baseline that we need for tracking very sharp turns of an object or something like that. It's just a resolution of a time series, but in basic, Ido got the idea that I had in mind right, that we provide each subscriber with individual parameters. And because this can be changed on the fly, it's suitable that we do it like this. Because just for detecting something, we do not need such a high timely resolution. It's just okay to have 1 frame per second. But if you want to analyze it, you step up the frame rate to max, let's say. And this can be done by just subscribing to this task.
Exactly.
And this is the beauty of it. Because you do not, let's say, one frame has got 35.5 megabytes. This really fast exceeds what we can do with the Ethernet.
For example, I get it, but
yeah?
I asked for real figures. So, for example, if there is an event, there's a plane flying over, and we decide on, I don't know, 300 by 300 pixels as the cropped size, whatever. Is it just a parameter you can choose? And then a new feed, I say stream, which is the wrong word, I know, that this image feed is then going to the tracker because the tracker said there is an event based on the full frame, and now I get subframes, not subframes, subsections of a frame, and I get it with higher frame rate.
Exactly.
What is the idea? I mean, the tracker, the tracker says, I see something, give me now a high frame rate of what? Of
that specific region.
Yeah, but if the plane exits that region, what then?
Well, no, it doesn't.
I'll explain.
Because you do not update. You do not update your position.
I'll explain. So think about it. This is a per frame kind of work.
Yeah.
Right. So the idea is, let's say that let's say we have 1,000 on 1,000. Okay, map. Okay, and now we see IIS somewhere around, let's say 1.1. Right, on X and Y, 1 and 1. Okay. Now, what I can do, I can ask now the driver give me on the box from 0, 0 to 5 and 5. Okay?
Okay, this logic has to be with the tracker then.
Yeah. The tracker is requesting that, right? In a much higher frame rate. So now the tracker is starting to work on these 5x5 boxes, and it sees what changes there, and it can now allows me to build what it's called a track. Like a target that has the history of all the previous tracks. And that's what we need to provide for the PTZ to move. Because we need to make sure that it's slowing and it's not like constantly moving all the time. So we need to have some prediction of how the object is moving and to where, so we can tell the motor how to move. So,
I mean, this stuff's like going over my head a little bit, just so that everyone knows. But that's fine. But yeah, so I do currently have in Simple Track, I have implemented some sort of track prediction. It's a bit kind of not worth terribly much at the moment, but I have tried. So I completely get where you're coming from as well with that sort of stuff, because
Yeah, but bear in mind,
I get it.
yeah, but bear in mind, it's not, it shouldn't be all in one component. So think about the topics, right? So
Yes.
and
I would like to. So this is probably a conversation that is going to be more detailed on implementation, and I would like to have a bit more of a conversation with you with regards to how far do you go with regards to slicing up, like for example, let's say Simple Tracker, and so currently the way it works is it draws frames using OpenCV, and it basically gets a frame, it processes that. There's state that is stored. For example, the background subtractor and the tracker needs to know about previous frames and data. So there's some state that is stored as it processes that frame, and then the next frame comes through, and it then uses the state that is currently there to try and predict and blah blah blah, all those sorts of things. And so the bit that I guess the question, one of the questions I'm gonna have, and this is more along the lines of, do we have like an image that comes in from the camera via ROS, and then there's the Simple Tracker that does its stuff, which tries to identify something and by blob detection and all, and then ultimately produces to a topic. It produces essentially a list of possible targets, or do you essentially take Simple Tracker and you divide it up massively into a set of, or like a set of ROS topics and services, and you make it really, you know what I mean? Like how finely grained, like for example, if I want to resize an image, do I call a ROS service to resize? And if I want to blur, or do you, you know what I mean? It's like, do you make it very chatty, or do you make it not very chatty, sort of thing, you know?
So the guideline in ROS2 is exactly you have like a topic per like a task in a way. So that's how, for example, the compression, right, is creating its own kind of feed, and now it's available, but it's never really running unless it's being requested, being subscribed to, right?
Yeah.
So all the image kind of how it's called, manipulation already exists in ROS. So you can subscribe to it, you can use it. You just need to install the plugin, and it's available for you, right? You need to transform it, you need to mask it, you need whatever it is, it's already there. Okay. But
is that because ROS2 has been developed heavily with computer vision in mind? So are you saying that we don't really need OpenCV when we use ROS2, because we essentially have
no. ROS2 plugins uses OpenCV already.
Okay.
They're using what you're familiar with. It's just like someone wrote a plugin specifically for ROS2. You can, instead of building it yourself, you can just subscribe to the topic, and it will know how to tweak itself into the raw data that you need, that it needs in order to do the transformation you want, right?
But this transformation is then processed on the Pi, for example.
Yeah, you can choose where to run it, right? Where you're running the plugin, that's where it will be processed.
So you're not doing this in you're not doing this in a Simple Tracker. You're doing before that.
No, so again, if we speak about a simple tracker is a subsystem that can have multiple topics inside, right? And multiple plugins. It's a collaboration of multiple plugins that are working together.
Ah, okay.
Yeah, I was thinking earlier on that I think in order for me to make Simple Tracker ROS2 friendly, so I need to understand, and this is something I need to research, is I need to understand and research more of the ROS2 plugins.
Yes.
But in order for me to make Simple Tracker ROS2, like write it towards almost like ROS2 not methodology, but the ROS2 approach is basically I'm going to have to start again almost. And so I have kind of thought that what I need to do is start rewriting Simple Tracker that is focused on ROS2. But now that you say there are already components available, I would be interested to see more about that, to be fair.
Yeah. So you can find a lot. This is, if you see my screen here, let me move it to the middle, right? So this is ROS2 real-time classification and detection.
Oh, okay.
Right? It uses OpenCV, right? It says that it uses the image tools, USB camera driver, whatever, vision messages that are already available in ROS2, right? And then it shows you how to run it and detection. And at the end of the day, this is what it gives you. Oh, sorry. It gives you, think about the transformation from a slash image or a raw image or whatever to a detection node if you want it, or a classification. The way it will work, you need now to subscribe to this. The moment you subscribe to detection node, you start receiving the detection feed.
Yes.
Right? And that will start work. Now, the way it will work is how you subscribe to it. And you can subscribe to it saying, I'm subscribing once a second, or I'm subscribing for as fast as I can, or I want it to be reliable. I want it to be delivered to me within a time frame, and that's what will make it real time, right? And I want to respond within a time frame. That will also provide me that I'm responsible for my real time aspect, right? So you're creating like a pipeline that is really real time, because you have time guarantees of processing.
Okay. If you say so.
Now I'll take it a bit more advanced. So it's important to understand. It's not that the message is being passed from the from slash image to this, and there is memory copy and all of that. ROS2 takes care of that under the hood using what is called a DDS or fast DDS. The way what really happens is you're going to get a pointer to the immutable data that you requested. If you want a raw image, you'll get a pointer to that raw image. Now again, given you're on the same compute node. If you're on a different compute node and you requested it, that immutable raw image will actually transfer over UDP to your compute node, and then you will get a pointer to that.
And that happens, that ROS does that.
Yeah, that's the magic under the hood that DDS does, actually. Fast DDS.
Okay.
To be more correct.
Okay.
Yeah. Okay.
So basically, what the next step would be is that you take you take the algorithm of the tracker and re-implement it within ROS2. So normally you would take a library from there and there and there, and these libraries are included in ROS2. So you just say, okay, I'm taking the library out of ROS2 and bind it all them together. And the second thing is, with just 1 frame per second, one is tracking where the bounding boxes should be, and then start a second instance of the tracker that is looking at the details.
Now we're talking.
And this And this is the beauty of it, because you have everything within ROS2, and you just have to recall it like, let's say, you have all the movement possibilities of a human body, and the brain knows how to direct, let's say, how to move the arm, and then the arm moves. And this is what we are going to re-implement for the AllSkyCam and every other stuff. So in BASIC, you take the algorithm of the simple tracker or smart tracker or whatever, and rebuild it within ROS2 with the services, let's say, as in form of general modules, generic modules,
Plugins, yeah.
plugins.
Yeah. Okay. Yeah, that's kind of the conclusion I've drawn as well. Is basically the ROS2 implementation is a replacement for Simple Tracker as it stands now.
Yes.
Yes. Yeah.
I wouldn't say a replacement. Okay. Think about it that I'm providing, like ROS2 will provide you the runtime and development environment for the simple tracker. And,
Yes.
and what it will require you to take the simple tracker CDs and breaking down to like single responsibility kind of plugins.
Yeah.
One
Yeah.
that
So
takes like
so I yeah.
yeah,
Yeah.
okay. One that takes like
So-
an image, and it doesn't matter what image, because from your case you need a slash image. It can be a raw image, it can be compressed image, you don't care. ROS will be responsible to optimize it.
So yeah. So I think the best route for me personally is if I take Simple Tracker and I convert it to how I see it fitting in with ROS, and I then show it to you guys. This is basically what I've done to make it work with ROS too, and then we basically go from there and say, yeah, okay, so this component can be replaced with this plugin, and this can be done differently. So because I'm not very familiar with ROS2, I think it's great though. By the way, before you suggested ROS2, I was in my head thinking of like RabbitMQs and all sorts of things. But so I completely get the ROS2 approach, and I think the ability to have it across more than one compute node, where certain compute nodes are specialized to certain things. I think it's great. I just have to kind of, I know how I figure stuff out. So I just got to kind of, I think, take an approach where I take Simple Tracker, implement it so that it is ROS2 friendly, or that it's based on ROS2, and then show you guys, and then we can basically go, yeah, okay, so this can be replaced with this plugin, which is better because it's maintained and blah blah blah, and yeah, so this is a good idea, but I think this could be done better, and that's a bad idea. That sort of approach, I think. But I completely get it. The only thing that I was my initial reservation is just to do with, so currently everything is happening in process, and I'm really pleased that you mentioned DDS and memory pointers and all that sort of stuff, because I was thinking that's kind of going to be network based. So I was just thinking currently everything is happening in process, so basically there isn't much communication over the wire. But from what you just said, my understanding is if you run, say, when we get to a point where we've rewritten Simple Tracker using ROS2, then we shouldn't have network latency or network overhead anyway, because a lot of the stuff will happen via DDS, which uses memory pointers. So we shouldn't, in theory, have a massive cost implication with making it more chatty using ROS2 services.
Yeah, so
is that correct?
Yes. Yes and no. So the end goal is absolutely yes, because you're relying on ROS2 to do that. Okay. Under the hood, we need to configure the fast DDS, which is the default protocol of Humble version of ROS2, we need to configure it to do that. Okay, not a big problem. So, but the moment we see that there is memory copy and stuff like that, and we see the problem, we'll step in and we'll start to configure it and fixing that. Okay.
Okay, but that's infrastructure level though.
Yes,
so that's
exactly.
configuration level.
That's a platform level stuff. Exactly.
Yes. Yeah. Okay. Yeah.
Okay.
Christian, I have a question for you.
Yeah.
So this means we will have less load, data load on a sleep ring on a PTZ, right?
Yes.
Yes.
This
is good
is
news.
exactly what it means.
Yeah, this is what I was worried about it, because sleep ring on a PTZ was kind of tricky picky to do it, and then especially if you think about mass of data now, is lots of data will be processed inside a PTZ, right?
So, can you guys see my screen?
Yeah.
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 Okay. So Nvidia also published this ROS Nitros. So again, when you configure it to work properly, there is something called an image and a ticket. Okay, and you can see how it knows how to optimize the pipeline so there is not a lot of memory copy between like CPU and GPU all the time, and it's really doing what it needs to do on the GPU and what it needs to do on the CPU to really optimize even that performance. Okay. So again, we will get there. Not important right now. Right now, I'm really focusing on the end, like on the end-to-end. Make sure that all the parts are there. But once we have all the topic in place and everything, we step in and start optimizing and make it real time.
And that's something you're familiar with, because if you're going to ask me to do that, then that's not going to go well.
I'm not familiar with it, but
Okay.
I'm familiar with the concepts enough.
Okay.
And in the other day, there is so many few ways of doing something like that. Okay.
Okay.
And when
No, that's cool. Yeah.
And when you have a platform that is designed to do real-time robotics, right? And you make a conscious decision to rely on it, and you see like the under the hood companies that are working on it. For example, there is also RTI DDS, and I suggest that you look at the interactive demo of it, like this one. But this can show you how you can subscribe to like a square that is moving like ping pong, and you can subscribe to it with history, and you receive always the history with it. So you don't really need the state as you are collecting right now. ROS will be responsible to provide you the state, the history of the tracking. Okay?
Yeah, so the only reason I do it that way is because I'm kind of dependent on OpenCV, right? So OpenCV, in order for me to interact with OpenCV, I have to work with its API, and its API requires some of this stuff. So
yeah, so what you do here,
that's the only reason.
Yeah, so what you do here, you subscribe, let's say, to the compressed image stream, but you say, but I also want you to give me the 5 most recent frames, as an example, right? So when you're receiving a new frame, you're always going to receive the previous 4 on top of that. And again, it's only pointers, so you don't really see much.
Can, for example, if an event is taken, can they also call the 10 seconds before the event happened? Is there a buffer of 10 seconds?
Yeah, so here you're speaking more about different aspects of a system, and I'll explain. Okay, there is in cybernetic systems, you have like the notion of memory, right? So when so the memory can subscribe to the topics and keep in memory whatever you want to keep in memory for the last 10 seconds, whatever, right? Mm-hmm. Then there is also the notion of recorder, okay, that actually can observe all the bus of all the published subscribe that is happening and can record everything. The reason for that, so you can do a replay, right? So there is a short kind of pre-alarm, with like 10 seconds, 20 seconds, 40 seconds, whatever that you need, right? And then there is the recorder itself that you can do really analytics on that and kind of record the scenario, see what went wrong, and then reply it through a simulation, okay? And fix your tracker to like improve your tracker, right? So you take it like to a backend, and you use the recorder now to do like replays, to do like machine learning and stuff like that. Make sense?
Yeah, I mean it's
the recorder uses disk. The memory doesn't. You don't need that on disk.
Yeah, no, it sounds really cool. I mean, it really sounds, and it sounds absolutely right tool for the job. It's just kind of obviously there's a learning curve and that sort of stuff, So there's going to be that, but yeah, no, it sounds really cool.
Yeah, so I'll suggest do the tutorials. They are not that hard. It will take you like several hours. Find the time if you want me to like walk you through with it.
No, it's fine. I'm fine with the tutorials. One thing I'm battling with at the moment is that current version of ROS doesn't play well with Python 3.9. I think there's some package which doesn't really work, so I've got to downgrade to 3.8, which I didn't realize. So
honestly, I don't know.
So it's yeah. So there's.
Oh, I have Python 3. Okay, let me see what I have here. I am using 3.10 here.
Yeah, see, so I can't. Yeah, so I have an error when I try to. So I use So basically, I watched a YouTube video. It was like a 2.5 hour YouTube video, which is an introduction, and the chap used. Sorry, just give me 2 minutes. Let me just quickly find the name for you quickly. He used something to compile the or to build the ROS package, and that was called. It was called.
So that's why I created the dev box. Yeah, so that's why I created the dev box. Okay, the only thing that you need on your like physical machine is RQT, really. But work on the dev box to do all the ROS stuff and your coding and everything like that. The only thing that is missing, and I need to find time to do that, is to map the local kind of development workspace into the Docker runtime. Okay, so you will have here like a workspace folder, and inside the world transporter we will have here all the plugins that we need, the Git and all of that, right? So you can walk inside this box that has all the versions. It's working nice. Everything is good.
Yeah, no, I understand conceptually. I understand where you're going with that. So I will try. I mean, I was just trying to follow through what the guy was doing, and then I was going to try and essentially, I was going to try and get it to work, and then basically I knew I could then try and rip Simple Tracker apart and put it back together again, in a ROS friendly way. Yeah. So that was, yeah.
Yeah, I will try probably next weekend to go again and do this piece, like to do the detection, okay? And it should be too hard to get there. But once I've done, you can see how the plugin works. You can look at by then I will have a workspace because I want to move to a workspace. But then you can see how it works and really like change it, right? Like physically change the stuff.
No, that sounds good. I mean, don't put yourself under pressure to get it done by next weekend, because I'm not going to be in a position to, So don't. You understand what I mean? So don't. So there's some stuff that I'm going to have to just get my head around first, and that might take a little while, because I only mainly have evenings and weekends to also think about with this. So.
Yeah. So there are more than one way to do like a detection. This is another example. Again, we only need to get that pipeline working. Once we have the
Would you-
pipeline working, then it's easier. We'll start developing all the plugin pieces.
Yeah. Would you mind just copying that URL into Hangouts just so I can grab it from there?
Oh yeah, I already posted all of these on the channel, on the Hangout channel.
Sorry. Okay.
No, that's okay.
I
That's
missed
okay.
it.
I'll send it again. Yeah, I'll send it after this meeting. It's like,
Yeah, that's fine. Yeah, of course.
yeah.
I have one question, Ido. So,
Yeah.
for example, the tracker is there to analyze images and to find an event. And then this event has to be somehow also messaged to other devices, let's say the kinematics analysis from Lionel, or the image recognition based on cropped images from that developed. So
think
is
about
there a
it,
back
like,
channel?
So think about it exactly the opposite. Okay, think about it as who demands this data, right? So, for example, if the website demands the data, right, because we want to show the video, right? The website wants to see the video as as a end-page stream, right? Needs to be more loosey. Doesn't need all the raw images and all of that. That's what it's going to subscribe to, okay? And then what will happen? A plugin will start to do the transformation of the raw images into this specific stream for the web for the UI. Make sense?
Yeah.
So if the UI now decides, hey, I want to see the camera parameters, just subscribe to the camera parameters, and now you start getting them, right? And now if you want to change them, there is a command to execute, like you publish an event that the camera driver is listening to camera parameter configuration changes, right? Like requests. And it will go, it will change that, the resolution will change, the frame rate will change, whatever you want will change. And from that, all the other pieces will change as well.
Yeah, this is one thing that's one of the reasons why I need to rewrite Simple Tracker, because of currently what I've got is I've got basically got a dictionary with configuration options, and I can see how that would plug into components, setting,
Exactly.
and all that sort of stuff. So I can, it's just, I guess my biggest concern is, well, not my biggest concern, but one thing that I still need to get a better understanding of is the tooling to run it. So, for example, if some people that might want to have one of these stations might not be that computer savvy. I don't know if I'm talking out of turn or not, but like they're not necessarily gonna want to understand.
Oh yeah.
You know what I mean? So is there tooling that basically would go and say, right, these components aren't running but need to be running, so we need to ensure they stay running, and those sorts of things?
Excellent question. So again, ROS2 is also like a runtime platform, right? It runs against a plugin, again, right? No, this is just like me installing plugins that already exist, right? But if you look at the makefile, right, what it is to do like a low res, you see that here I'm just running the camera driver and I'm giving it, this is the pixel format, output encoding, whatever, that again, I can change the runtime, the image size. This is just like the kickstart in a way. Now, notice here that there is nothing about compression, nothing about all of that. Because the plugin compression is there, it detects that there is a raw image, and it will make, hey, if you want, I actually can offer you a compressed stream. So once you subscribe, it will start working. Okay?
Yeah. I really that part is key. Is to understand it. Is that it draws the information. So if it wants the information, it can attach to the publisher and essentially draw that information stream. If
Exactly.
it wants something else, yeah.
Yeah, so when we create a tracker, really think about that we create all the bits and pieces of the tracker using like topics. So when you have like a tracker configuration, look at how the camera parameters is implemented, because it needs to be like the same way. So we can change the tracker behavior in runtime, right?
Yeah, I'm not quite there yet. So I'll
No,
probably
that's fine.
if you give me a couple months. But yeah, no, I understand. I kind of I get it. I just need time for it to soak in
Yeah.
and kind of actually do it, if that makes sense. But
Oh,
I
yeah,
like it. I'll
absolutely.
tell you that.
You're not the only one,
Yeah,
mate.
it needs,
Hey, Ido,
it needs some time to have, yeah, go ahead, Richard.
my question, maybe I put it differently. So, when I get the ROS idea of every little part in a network does its things, and everything is cross subscribed. In our case, so for example, we have a central software that controls all events, meaning our ROS2, I don't know, server, I don't know whether you can name it that way, and other devices are subscribing to because they get data. So what in the case with the simple tracker, it detects something, and this detection, like let's say the center coordinate wise within the frame, shall then be propagated to other
Exactly. So
elements.
the tracking
So
Oh,
responsibility,
you'll
who is
just
then,
publish that.
yeah, who is subscribing and who is providing?
so the tracker
So
responsibility is to convert in the beginning a stream of images to a stream of detection. That's the first step. Now, when you have detection, you want to subscribe to the detection with history. Let's say the last 5 detections, right? And that will give you the capability to do fusion, okay? And create a prediction to another stream. And now you're creating another service or another plugin that will receive the predictions, and that's what the motor will be responsible now to get commands and move towards it. Okay? The
Now my
UI can
question.
subscribe to it and can see it if you want to.
So you mean that simple tracker is also propagating something that let's say the kinematics is subscribing to?
Yeah.
Okay.
Richard,
So every
so
node
can
is
I
also a
just
node for others.
Yeah.
Richard? So currently in Simple Tracker, like I'm going to try and just currently in Simple Tracker there are there's the ability to write out video. You've got this idea of subscribers and publishers, and one of the subscribers is basically to write out those JSON files. Those JSON files and the little bit of video that comes with that, and it used to write out, or it can write out a subfolder, an image subfolder that is full of images as well. Do you remember that? Do
I
you
can
know what I'm
remember, but
referring
the
to?
idea of ROS2
So
is a different one, isn't it?
yeah, so basically all Simple Tracker will do is just essentially publish to say, the bounding box coordinates. There will be one thing that just says bounding box coordinates. These, this is basically what I'm tracking. The bounding box coordinates, and it's something else's responsibility then to go, right, I'm going to grab the image from here. I've got the bounding box coordinates from here, and I'm going to make a JSON file, for example, to record the history of that.
Exactly. Yes.
I'm
It's
more thinking into,
it's
for
very
example. Yeah, excuse me.
No. I'm just going to say it's I don't quite know how to explain it. It's you have like little components that are responsible for small little things, and that's all they do.
Yes.
And
That's
then you
called
got
microservice architecture.
Yeah.
yes,
So
yeah.
in
I
this
just don't
case,
know. I don't know how to.
in this
Thank
case, please correct me if I'm wrong. In this case, we have the master control program taking care of, let's say, the base subscriber for the camera, for example, publisher for
Yeah.
the camera. So the simple tracker subscribes to the master control program, saying, "I need this feed." Yeah? And then it finds something. My question is now, is it now back propagating to the master control program, or is it by itself collecting kind of an almanac of all kind of events, which it has to provide to another node? For example, kinematics will then know what are the last 25 tracking points, for example. So what I want to say is it a centralized like a star, or is it a mesh network where every node also is a server, is also providing data and
Yes.
where others
So
can subscribe to?
Yeah, so think about it as a mesh, okay?
Yeah.
It's not a single process, it's multiple processes, processing working together as a unified subsystem. Okay? Same way as you have in hardware, right? You have a chip, you have transistors, you have that, and each one is doing one thing. But you have like one PCB that is a subsystem. Same thing with the software.
If you just think about a car engine, I guess, and you think there's something that basically produces power, there's another component that generates enough electricity to charge a battery, there's something else that pumps water around the car, and all those things are individual components.
This is simply
and
said,
then you
this
have
is more or less action-reaction based. I mean,
I'm just asking one thing. Let's not speak about cars, please. I can't speak about cars.
So, kinematics module will then subscribe to the simple tracker for getting track points, right?
Yeah, in my opinion, I think so. Yeah, so it wouldn't be called a simple tracker anymore. It would just be called something that like a kinematics service or something that basically just it publishes that data, or you can get that data from that service or from not that service, because that's from that topic. You can get that data from that topic, and then it's up to you to do with that data whatever you want to do.
Mm-hmm. Yes, Patrick.
Does that mean that every component needs a root component to itself because of that? So, for example, the tracker itself needs now a universal tracking component. So.
Sorry, just say that again. You just cut out there. Sorry for me.
Is this now meaning that every component needs its root element? For example, the simple tracker now being split up in components that do background subtraction, the other components does whatever. And
I wouldn't say
one root component to it. Pardon me?
I wouldn't say it's split up. Okay, the simple tracker is a larger subsystem that has smaller components inside, each one responsible for or responsible for one action, right? And again, the easiest is think about object detection. Object detection is basically a function, right, from an image to a box, right? That's what it is, right? So the idea is that we are describing this. Okay, we have a function from an image to a box, okay? And now we say, hey, I'm a component that can do that, right? So now there are components that say, oh, I'm actually interested in a box, and I can do a function from a box to a tracking history, and I can give you a prediction of the movement, right? So that's another function.
Whatever it does.
We are making like function compositions of different plugins part, and eventually the entire composition of what the simple tracker is responsible, that's the simple tracker. So it's a collection of these composable functions. Because if you think about it, the way the process works, you have like a computer, you have an input, you have processing, and you have an output. And it's basically a function from an input to output, right? And what we do, we say, okay, what's the topic and what is the type of the input and the type of the output. And once we define it, we just need to implement it.
Yeah, so basically it's a mesh network. It's not a star-shaped one, so that you have just one service and everyone reports to the same service. It's
No, it's
yeah. So you have to
yeah.
you have to
There
know
is
about
no,
you have to know about a node in order to be able to subscribe to, right?
not exactly. So there is a discovery in ROS2 because it uses UDP, right? So you see, for example, when I run RQT, right, it's actually listening to UDP packages about what topic are available. And this tool allows me to subscribe to whatever. I can subscribe to parameter events, I can subscribe to ROS out or whatever, right? And each one will give me something. I can create a call to action, I can execute a topic, I can publish myself. I can do like a ROS2 space topic, publish, and say hello world. And now whoever is interested in that will receive it.
And I can also subscribe to several nodes, not only to one.
Yes.
Yeah, of course.
Yes.
In parallel.
In parallel, yes.
Lionel. You're muted, Lionel.
Yes, Lionel. No, you're good. You're good. I can hear you.
Really? I can't hear him. Okay.
Yeah.
Did we lose Richard?
No, I'm there.
Oh.
I have to.
Okay.
If I don't hear Lionel, I have to go out and in again.
Can you hear me now? I'm
Yes,
talking.
yes.
Talking
You're
and
now on
making some
record.
noise. Yes. Good. Okay. So the kinematics model, does it have to run in ROS as well? So it has to be like a module that's in the ROS runtime environment.
So again, there is no like ROS runtime environment
Okay.
in a way. Each node run ROS components, right? That are self-discarded. They're letting everyone know here is the topics that are available and this is the plugins that I'm running and all of that, right? As for the kinematics, you can use a ROS2 kind of web a client that will make you that allow you to show the visibility of all the topics that are available and what you can subscribe to and what commands you can take.
And you can in turn can you publish things
Yeah, you can
to,
publish even
to
new
ROS
stuff.
to which the PTZ will in turn subscribe.
Exactly. Yes.
Okay.
Exactly.
Okay. So
Okay.
okay, cool. So I just take the Docker and start from there.
Yeah. I think the Docker is the best place kind of to start. I
Okay.
already optimized the latest and greatest there. It was actually really straightforward.
Okay.
And
Cool.
I
Thanks.
find actually compiling ROS2 be far more challenging than just using the Docker and do an upgrade. It's working much better.
I have another question.
Okay, thanks.
You said that those nodes, those ROS2 nodes, are used in several, for example, for the tracker with several sub-modules of the tracker. For example, you mentioned that you go, let's say, for example, with a 1 frame per second on full frame, and if there isn't detection, then you go on 20 frames per second with a subset, for example.
Yeah, so think about it this way. The tracker has like the full frame object detection that working, let's say, once a second, okay? And then it detects boxes. Then there is another plugin in the tracker that is subscribing to these boxes that the 1 Hertz is working on. And it says, I'm going, at the moment there is a box, I want to subscribe to the high accuracy stream with this box, right? And now it's going to receive, or I need that, and it's starting to receive that.
Yeah.
And it's starting and stopping that subscription all the time. So the plugin, the driver plugin, is going to start another thing, with much more frequency when there is the subscriber for that.
Yeah. Okay. In our case, if there is a process that only runs with 1 frames per second, then it should always run a process with 1 frame per second. So let's say the one that is basically detecting something, and then another process is forked that goes with the higher resolution. Is that basically the idea? Christian?
Yes, you can say that. Yes, and again, I will try to right now not to focus on the performance, okay, and all of that. We can do everything slow. We can do everything, and let's say 1 hertz or whatever. See that it's working, and then start to optimize it, make it like more real time, more higher performance.
Yeah.
Okay, it will not be straightforward to have a driver. Just so you know. That it changes and read like boxes and do real time. It's a complex driver, but it can be done. It's designed to do stuff like that.
Yeah.
First we get it running and then we optimize it.
Exactly.
Yeah.
This is the strategy.
My question is more oriented in because it's everyone is a node. Everything is a node, and some nodes can run on the same board. But if we run out of performance, we can take that node to another board. For example, it could be that the 20 frames per second process needs another nano, for example.
Yeah, so that's why I'm saying right now what is important to have it running. It can run on a desktop. We're using USB camera, using a simple detection to detect whatever. Because we can change it eventually to detect only what we want. Okay, but as long as all the streams are there and we can, increase the accuracy, reduce accuracy, and all of that, that's when we decide, okay, this is how it's going to run on the embedded hardware, right? Mm-hmm. Now here you can go very far. Mm-hmm. I can show you, even how to write like a Rust program, that will compile directly on the Raspberry Pi. So you don't even need an operating system. Okay. Again, and you can use ROS2 with it. Read from the network. Do that. It's the lowest level you can go, and that's going to be full kernel mode real time. Mm-hmm. You can go crazy here. I wouldn't recommend it, like writing embedded Rust. There is so much that you need to configure, the bootloader and all of that. But again, you have this capability if you choose to. That's the whole idea of improving performance. Okay?
I see.
Okay, I'll suggest, use your default web camera. Do the object detection on that, making sure all the parts, make sure the kinematics works on top of that. The web works with that. It's fine that you're detecting like head movement, smiley face, I don't know what. It doesn't really matter. We will improve that. We need that end-to-end kind of system working. And then we can take even a simple, I don't know, there is this Lego stuff that costs like $20 with a simple motor that can move, and we can start telling it to move to whatever direction. See that we get those pieces, okay? And we'll keep improving.
You're still with SkyView 60, you know?
Yeah. Yeah.
Okay, it should be a joke.
I didn't get that. Sorry.
Just don't say I'm gone.
I'm what?
Just don't say I'm gone. Bye-bye.
Why would I say that?
Well,
then we're lost.
Some people say that.
Look. I enjoy this. This is pretty much my life, right? Like working on this kind of systems. The way I see that, I live, I just don't see that, right? I might have difficulties, particularly with all the rabbit hole stuff that are happening. That's rough on the mind. And then there is, normal kind of, life events, work events. But other than that, this is great. I don't
Okay,
know.
I think Buel meant it in a way that if we implement ROS2 and you directed everything and then you step aside, then we are lost.
Yeah.
Oh,
I wouldn't say it. The
yeah.
idea of ROS2 is that if you understand or have understood what it is doing, it gives you a different way of thinking, and it gives you a different way of coding things. So you're just coding modules, plugins, and so on. And only the algorithm is what you have to focus on. And if you make ROS2 one part of yourself, then you do not have to think, okay, how do I have to implement it in such a particular language? Because you can use the language you want to and just hook it up with it. And it is like a third hand that you can use.
Yeah, I mean, it's quite conceptually it's a well-trodden path. The whole messaging systems. The only thing I think that, like in my experience with messaging systems, is you deal with something called eventual consistency. They generally don't work real time, like the ones that I'm familiar with. So
No,
the real time notion of a messaging system that can be real time is quite a novelty for me personally. I think it's quite cool.
yeah. So eventual consistency, that's the only way to really do.
Yes.
Okay, because
So many.
if you require strong consistency, you are sacrificing your real time.
Okay,
Now,
so even with ROS2, we're dealing with eventual consistency. Is that
yes,
okay?
yes.
Okay,
It's again,
no, that's fine.
but again, you can subscribe to events and says I want to have a reliable stream, which means you never lose messages, right? I can tell you for the tracker, it's not important if you lose a frame per second, so don't
No,
subscribe in a reliable way. It's not
yeah, no,
important.
I understand that. Yeah. No, I get that.
It's more important to be real time. It's more important to be eventual consistency. Lose as long as you are processing always the latest and greatest frame. That's what's important, right? If you are doing a recording, that's when I will tell you there are two ways to do recording. There is an intrusive way of doing recording when the recorder physically subscribes with reliability, and now it's guaranteed to not lose a message, or a non-intrusive way, which is actually being an observer to the system, and whatever messages it's interested in, it reads from the UDP that it receives and writing it to disk, right?
Okay.
In real-time system, most of the time, you want to be a non-intrusive recorder because you
Sure.
don't want to impact your system performance.
Yes.
When you record. Okay? With that said, there are point of interest in a cybernetic system behavior that have high interest for you because you know the system might go to a malfunction. And that's where you want to intervene. You want to have a reliable recording, knowing that you are sacrificing the real-time performance, okay? For future analytics to improve the artificial intelligence and improving the reliability of the system in a new AI model that you're going to deploy. Right? Does that make sense? Or I wish I could describe some use cases.
No. I think I personally I think I get it. It's just a bit to take in. That's all.
Yeah.
So it is.
Now it's very important to understand ROS2 is an open source platform. Okay, there is a huge community building all kinds of robots with it. Okay, industrial robots to the industry, the robots that are fighting each other in the ring, there is drones. There are just so much, and getting involved with that community, with our project, is probably very important, because we might get some interest from some people that really know ROS2 that can help us and maybe are interested to contribute. So I'll suggest it's a good idea to actually reach out to the ROS2 community, say, hey, we are Sky 360, who wants to have discussion with us around the architecture? What's the best approach to, build our workspace, whatever. I'll do some stuff, but there are people way smarter than me doing it full time that are far more capable on building something quick.
I think that's true for all of us, mate, to be fair. I think we
no,
all... So, I mean, just to... Like, I bought a book on OpenCV at the end of last year, and I've never used it before in my life, and so it's all just a lot of patchwork and stuff, so it's part of what makes it fun, I think. But yeah, I get where you... I completely get where you're coming from.
Yeah, I mean, again, we are an open source project. Like, it's good to deal with other open source projects as well and collaborate.
Definitely.
It's always working better. And if you want to gain popularity with Sky 360, it's also to reach out to influencers that are building videos around ROS2 or building apps like in a 2-3 hours video, right? And give them materials to do a video with us. So collaborate on that. We don't need the money from the YouTube video. They can take all of it. We get the knowledge of how to do that from them, right? And we might get also some subscribers, because some of them have, some of the YouTuber I follow have like almost 1 million followers.
Wow.
And they create like stuff like someone created it's his own Vim editor, 8 hours video from nothing to something, right? They are totally capable of running an entire video building something, which is nice. There is a lot of again YouTube video around ROS2, object detection, YOLO. It's just packed with it.
Yeah, I just got to bear in mind, I've got a life. I've got to try and have a life as well.
We all have
Do
a
you
life.
really?
I try.
Can you try not having a life?
I have in the past, and that didn't end well. So no.
Yeah, what's this life thing I keep hearing about?
Yeah.
What is this?
I think
it's a struggle.
Not really. If you think it like this, working on Sky 360 with ROS2 can be some kind of state of mind. It's like having, let's say, this room in your head where you it has some Zen style. You can lock you away with it if you have trouble on another side in your life, and you can use it to focus. And
yeah, mate, I'm not buying. You keep on selling. I'm not buying.
Hey guys, I have another topic, and involves ROS2 probably. So Aussie Joe from Sydney, he tested ADSB. So he tested the one example is the no-LAC Nano 2 SDR ADSB receiver. It's available on Amazon, and it does what it shall do. It comes with antennas, and you have a reach of, let's say, 70 kilometers, which is pretty okay. I mean, there are bigger antennas and you can go wider, but 70 kilometers is pretty neat with a standard packet. Now comes the question from Joe. There's a lot of software that can be used with this equipment, but none of them is kind of an open Linux version where you can pass parameters or get an output from. So how can we go about to find a Linux tool that reads out from the no-LAC and also creates those ROS2 messages that can be subscribed from the user interface, for example? or from the simple trick, or for the master control program referencing whether a plane is a plane.
I don't know, man. I think we got to. Yeah, I don't know. Is that something we can maybe pick up down the line?
Is there a plugin for ROS2 for ADSB receivers already?
So I can look if there is like a ROS2 plugin already for like SDR, but that will be my best kind of thing, like an SDR driver, right?
Okay.
With ROS2 plugin that allows you to configure what you want to record, and then you'll have a stream of topics with the raw data that is coming from the SDR, right?
Okay, can you
From
have
the actually from the hardware, and you build the SDR on top of ROS2. That to be more correct.
Yeah, but the hardware is existing. The hardware is just a sensor that gives out the datagram. No one is producing such on ROS2 for now, I assume.
Not sure what you mean produce on ROS2.
Yeah, you can't buy an ADSB receiver that has ROS2 implemented.
Oh, really?
You can or you can't? What mean, really?
Like my idea, just before I joined Sky360 was actually to build like all of this what I call robot parts, or take all of these sensors and building for them a ROS2 driver, like embedded.
Yeah.
So they are all speaking ROS2, and then you just plug and play, like the physical hardware, and then you build the brain with your computer.
Yes,
right?
if you can have access to the firmware of the hardware and can directly communicate via ROS2. But in that case, these are equipment that we have to buy from the shelf. And I'm not aware of any ADSB that is ROS2 capable.
No, so you build it as a software-defined robot part.
May I interrupt there? There is an SDR implementation included in the OSRF part of ROS2, and you can connect to the driver if you make it available for the NoAlic, for example, and you can use it right away. And I think the software on Linux that you can use is I have to look it up, and you can run it within ROS2 already because it just collects data.
Okay. Can you
guys?
provide
I'm gonna have to.
For Joe?
Yeah, just a minute.
Mike, what did you say?
I'm gonna have to jump off in a bit because I've got a guest here at the moment, so I'm gonna have to bail. Okay, in a bit.
Don't they want to learn about ROS2?
Sorry, mate, you were saying?
Whether they want to learn.
Yes, probably want to learn about ROS2.
Yeah, no, I think my buffer's full at the moment, so I've got to just kind of I've got to work through it first a little bit, but as I say, conceptually, I think it's great. I've just got to kind of just think it through, and basically, I guess one of the things that it would be worth chatting about is this alpha version that you guys are wanting to do. So I think that current simple tracker is probably going to almost be the best I can produce for an alpha version. There's some bits and bobs that we can maybe tweak with parameters and that sort of thing, but I don't know how much more. One concern I have is we have to produce something, right? So at some point we have to produce something, and I'm just wondering if the current version of Simple Tracker is enough to be an alpha version.
Absolutely.
In a way.
Absolutely. It detects, it does what it does. Certainly there is room to move.
Do we have enough time to implement ROS2 in alpha version?
Yes, we have the target.
No.
Or just a
yeah,
part
Because
of
we
it.
do.
Just a part of it.
Yeah, but it depends if you want to. It depends on. Yeah, so we can. I can do it, but it'll take me a little while to get it done. So, and you're not gonna. It's not gonna be. Well, yeah, yeah. So I don't want to say. I kind of want to say there's not going to be any improvement because it's more platform level than kind of we're using a better background subtractor or a better tracker or that sort of thing. I'm just wondering if we can just maybe draw a line under simple tracker at the moment and say if someone wants to run it, because I have it, I've hooked it up on a video camera currently, and it captures stuff. It doesn't capture everything, but it does its thing with a video feed on file and a video camera. So I just think it's probably it's a start, and I just feel like we need to produce something. You know what I mean. So it was just
no shame.
I was hoping you guys could ever think about that.
The simple tracker is perfect for its stage, absolutely. So for a first issue, if that we can call that the alpha, we do not have to shy away. And I think it's much more important if we all decided to go for ROS2 as the infrastructure, to implement that infrastructure with a tracker or build a tracker around ROS2. I don't know whether this wording is right.
Yes, agreed.
But you get my word. Because
yes,
to have something high sophisticated which is not integrated doesn't make any sense. It's better to take what it is and be happy that it is like it is, because I think it's a wonderful tracker. It can certainly improve, but it's a perfect start. And I think it's more important to have it integrated with ROS2.
Richard, like Idle said, we can do piece by piece.
Yeah.
This is like a Lego
Baby
system.
steps.
We can implement the ROS2 piece by piece. Right, Idle?
Yes.
Yeah.
What's important to really understand about ROS2 is that the mantra there is don't reinvent the wheel. Okay. So if a plugin is there and you need more functionality, work on the driver that is there, improve that open source. Okay. And they are starting to consolidate different implementation of drivers to achieve that, right? But it's all about improving what we have. Don't reinvent solutions. Okay, and
Yes.
it's very big. The way you build it, it doesn't matter if the driver now is going to publish the raw images, or the recorder is now going to publish the raw images. And that's the difference between what it's called hardware in the loop and software in the loop. How you do how you move from real-time physical world to a simulated world. Okay, but everything stay the same, and that's how you can do compare. That's how, when you speak about today, like in cybernetic system, there is the digital clone, right? How to improve in real time, or how to create this feedback loop into my AI model to improve. And the way you do that, you run, the physical hardware, you're getting the data, you're sending it also in parallel to the digital clone, right? That then most likely will divert when there is inaccuracy, give different accommodation, and those are going to be feedback to the AI model for improvements.
So ROS2 is much likely event driver, real-time event driver.
Yes.
Driving.
Yeah.
Mike, see it like this way. The most important part of what you did so far is inventing the algorithm and not the implementation. The implementation is just what follows, but you invented the complete algorithm of the tracker. And if you just have to reorientate it, so just by saying, okay, I do not connect to this library or to that one, and you say, okay, it doesn't matter to which library you connect because this is already implemented, and this is what Ido was referring to with the metaphor of the don't invent the wheel again. I don't think that it is that much that has to be done to get an implementation for ROS2 because ROS2 has already everything there. And what's not there, we will invent it. And I think it's not that important from where the parts come, but it's more important what your work already did, inventing the algorithm.
Yeah, Christian, you really don't have to make me feel better, mate. Honestly, don't worry about that. I've been a professional software dev for a number of years, and I've written a lot of stuff that has been binned and has been no longer used because of so it's just part of the process. So honestly, don't I completely get it. I think, and I completely agree. I think if there's something out there that's better than what I've done, then we use that. I mean, don't ever think I have some sort of affinity or some sort of affinity to the stuff that I write. I mean, it's great. Don't get me wrong. But I'm not tied to it. If there's something that does something better than what I can do, get rid of what I've done and put it in its place. There's no so please don't worry about making me feel bad because we're gonna have to burn Simple Tracker. It's really no biggie for me, honestly. It is just part of the process.
So you're a solid software engineer, and here is. The more experience you get as a software engineer, the less attached you are to your code, but more to the experience that you learned from it. And then it doesn't matter. Like you see frameworks, this is better, and you just move to that.
Yeah.
But
no,
what
absolutely.
You know the experience, you know what you're going to get. So it's always getting better.
Yeah, it's just how it works. It's the industry. It's not, and if it's just how the industry works. And if it's not something, if it doesn't work for you, then that's fair enough. But it's not going to change. So I completely understand all that sort of stuff. So please don't please don't feel you have to be very what's the term now is. You don't. It's not sensitive. It's not like if we have to burn Simple Tracker to replace it with other bits which are better written. I'm cool with that. It's no biggie.
But we are not Simple Tracker or Sky 360 Tracker. Let's use proper name. Sky 360. It's a concept. Okay. The coding.
Yes.
Okay. Is the coding for it? How to do that? You're gonna have. Let's say that we use it right now on 100,000 systems, right? Now come the next version, right? And the next version, and then we say, we need better performance. We might need to end up writing it, I don't know, in C. Doesn't really matter, right? But we learn from it. We have the experience from it, so we always can improve on it, right?
Yeah, no, you're absolutely right.
But keep it as the concept, not as the code is not the concept. Code is just code.
Yes. I mean, I've just been fortunate in my professional career. Most of the software I've written is actually made into production and actually running. I know a lot of my friends that are in the industry spent years writing stuff that have just been dumped. So, it's just how it works.
Yeah.
I put the link to GQRX SDR in our chat here. So you can take a look at it, and I think it can be run as a node in ROS2.
Cool.
I'm going to have to bail, okay?
All right. Thank you, Mike. Thanks for showing up.
I'm going to have to jump. Thanks. Yeah, thanks for preparing it in Ido and everything. Yeah, it's been really insightful and very informative. So thank you very much.
Sure.
Bye-bye.
Bye.
Guys. Bye.
All right. So Have we spoken enough about ROS2 for now? Or are there urgent questions? Okay. I think either there are too many questions to formulate them right now.
Yeah, that's fine. I mean,
I think it's a wonderful idea to do that way. I just have to wrap my
Agreed.
mind around it, how it works, what the meaning is, and so forth. What it means to us, what it means to the concept, what it gives us for possibilities, for flexibility, and so forth.
You know, the most important thing everybody of us need to, especially me with hardware, I need to mess a little more with ROS2 from the simple things, you know, so I can better understand, you know, whole thing.
yeah,
Bigger thing.
I'll suggest the better way to start if you don't want to, put your hands dirty with ROS2 is really create like CLI tools, that do like one thing, like, execute a command and give you an STD out, the output. Okay? If you have that, converting into a ROS2 kind of streaming approach will be straightforward.
Okay,
Okay?
thanks.
So, for example, like a CLI that will say engine move left, engine move right, or move 10 steps left, slew this speed for the next 5 seconds.
I'm already doing this with encoder and motor and try
Nice.
to get smarter
Cool.
on the ROS2.
Yeah, nice.
Sweet. Okay, guys. If there are any other questions, if there are not, then I'd say we wrap it up for the day. First of all, I say thank you very much, Ido, for having joined us and
Yeah, absolutely.
Yeah, that's very informative.
Yeah, very informative. Yeah.
giving your inputs and helping us further on. Thanks for that.
Yeah,
man.
yeah, absolutely.
Okay. If there are no any further questions, I'd say we wrap it up for today. I stop recording.